In this video, we're going to cover unit conversions and how to use conversion factors. Let's say we're trying to convert 60 miles per hour to units of feet per second. We want to multiply 60 miles per hour by a conversion factor. Now, it's important to realize that we're not wanting to change our quantity. We simply want to express our quantity, which in this case is speed, in terms of different units. Therefore, our conversion factor should only convert the units, but not change the amount of speed our number and units represent. So to do this, a conversion factor should be equal to 1. This way, if we multiply by 1, we won't affect the amount of speed we have. To get a conversion factor, we need a relationship between two units. Examples of these relationships are 1 mile is equal to 5,280 feet, or 1 mile is also equal to 1,760 yards. 1 foot is equal to 12 inches, and 1 hour is equal to 60 minutes, or 3,600 seconds. Sometimes these are called conversion factors, but I just call these equalities or relationships between units because we're not ready to multiply by anything just yet. In this example, we want to convert our distance in miles to distance in feet. So we'll start by writing 1 mile is equal to 5,280 feet. Both of these are equal to 1 mile, so we can divide by 1 mile on each side. Now we have 5,280 feet divided by 1 mile is equal to 1. And it should, since both of these represent the same distance. We could just as easily have divided by 5,280 feet on both sides, and this would give 1 mile divided by 5,280 feet equal to 1. These are both conversion factors, and now we just need to choose which one we want to use because we will get very different answers for each. We'll begin with our first conversion factor, 5,280 feet over 1 mile. Doing this, we can see we have a unit of miles on top and miles on bottom, which means they will cancel since this is just equal to 1. This leaves us with units of feet per hour. If we were to use our other conversion factor, our units are drastically different. Now we have miles times miles, or miles squared, divided by hours times feet. The conversion factor on top has given us units of distance that we want, but the conversion factor on bottom seems to have made things much, much worse. By keeping track of our units, we can easily see when we've used the correct conversion factor or the wrong one. Now let's go ahead and finish getting our quantity in feet per second. Our feet are taken care of, so now we just need to convert hours to seconds. We'll use our relationship of 1 hour is equal to 3,600 seconds. This gives us two possible conversion factors. We can look at this in one of two ways. We want to have seconds left in the denominator, so we know our conversion factor should have seconds in the denominator. Or we can see that we want to cancel the hours that we currently have in the denominator, and to do this, we will need a conversion factor that has hours in the numerator. Therefore, we'll multiply by 1 hour over 3,600 seconds. Canceling our units, we're left with feet per second. And now we just multiply through and find that 60 miles per hour is equal to 88 feet per second. Now let's look at converting units that have exponents. We'll use the example of converting 3 meters squared into millimeters squared. When working with metric units or units in the metric system, we'll see prefixes on the units and we should know the common prefixes. I'll list several of the common prefixes here. Nano, micro, milli, centi, deci, kilo, mega, and giga. There are many more than this, but for a class like Physics 1, you should definitely know a few of these, milli, centi, and kilo for sure. And for other classes like Physics 2 or Chemistry, you'll need to know prefixes that represent really large or really small magnitudes of numbers. These prefixes each represent an order of magnitude or power of 10. And anytime we see the prefix, we can just replace the letter of the prefix with its order of magnitude or power of 10. To show this, I'll write 1 millimeter equals 1 millimeter, which is obviously true. On one side, say the right side, we'll just replace the first m representing the prefix for milli with 10 to the power of minus 3. And simplifying this, we get the relationship 1 millimeter is equal to 10 to the minus 3 meters. Also, if you don't like negative exponents, then you could just multiply both sides by 10 to the positive of whatever exponent. For example, if we multiply both sides here by 10 to the positive 3, we get 1,000 millimeters, or 10 to the third millimeters, is equal to 1 meter. And now we have a relationship that doesn't involve negative exponents. Now, we know we're going to want to go from meters to millimeters, so we'll use the conversion factor 1 millimeter divided by 10 to the minus 3 meters. But this will only cancel one of our units of meters, and will only give us millimeters, not millimeters squared. To resolve this, we can just square our entire conversion factor. Since our conversion factor is equal to 1, and 1 squared is still 1, We won't hurt anything by raising our conversion factor to an exponent, but we do need to be sure to raise the entire conversion factor to the desired exponent. To see that this makes our units work, we can distribute our exponent to every term inside the parentheses. Doing this gives 1 squared millimeters squared over 10 to the minus 3 squared times meters squared. Now we can cancel our meters squared and simplify. The only units that are left are millimeters squared, which is what we want. Plugging this into a calculator, or simply flipping the sign of our exponent and bringing our power of 10 up, we get 3 square meters is equal to 3 times 10 to the 6th, or 3 million millimeters squared. So there are 1,000 millimeters in 1 meter, but 1 million square millimeters in a square meter. And this is because our 1,000 gets squared. Numbers can get very small or very large when converting squared and cube units, so be sure to follow these steps. You'll find your conversion factor as usual, ignoring any of the exponents. Then, once you have your conversion factor, raise the entire thing to the exponent you need. Notice in our examples, this is the exact same thing as applying our conversion factor twice, each time canceling one of the meters, and each time we gain a factor of millimeters. Now, if you follow these steps, you can use relationships between quantities that you might find in a textbook or online to convert any units. We'll do a few examples for you to test your knowledge and continue to get the hang of this. In the first example, we have the speed of sound as 342 meters per second, and we want to convert this to units of kilometers per hour. 1 kilometer is equal to 10 to the third, or 1,000 meters, and 1 hour is equal to 3,600 seconds. We want to be left with kilometers on top and hours on bottom, so we'll use these two conversion factors. Now we'll multiply by each one and cancel the units that appear on both top and bottom. I like to circle the units that are left to make sure I didn't make any mistakes, and we find that 342 meters per second is equal to 1,230 kilometers per hour. The next example gives us the density of water in grams per cubic centimeter and asks us to find the density in kilograms per cubic meter. To do this, we'll need to know 1 kilogram is equal to 10 to the third grams, or 1,000 grams, and 1 centimeter is equal to 10 to the minus 2 meters. Now we multiply by both conversion factors, but our conversion from centimeters to meters will only cancel one of our centimeters on bottom and leave us with 1 factor of meters. So we'll need to apply this conversion factor 3 times, or cube it. I'll distribute the exponent so I can cancel my units, and we're left with 1 gram per cubic centimeter is equal to 1,000 kilograms per cubic meter. Now we'll do a slightly longer example, even though it's not any more difficult. We want to convert the speed of light in meters per second to miles per second. I personally do not know how many meters are in 1 mile, but I do know there are 2.54 centimeters in 1 inch. And if you didn't know this conversion, it would most likely be in a textbook. This means we can convert from meters to centimeters, then use this conversion to go over to inches, and then from inches we can go to feet, and then feet to miles. It's always good to lay out a course from one unit to another when you know there's going to be many steps or many conversion factors. I'll multiply by each conversion factor and carefully cross out units that appear on top and bottom. Doing this leaves me with miles per second, and after carefully putting these numbers into a calculator, we get 3 times 10 to the 8 meters per second is equal to 186,000 miles per second. For our last example, we'll convert 4.5 liters to cubic centimeters, which are sometimes abbreviated as cc's. To do this, we'll need to convert liters to milliliters, and then there is a convenient conversion where 1 cubic centimeter is equal to 1 milliliter. I'll multiply by both conversion factors. Notice that even though the last conversion factor is just 1 over 1, so I don't have to multiply by this factor in my calculator, I still want to write it down to confirm my units are going to work out correctly. And if this were part of a much longer conversion, it would be even more important to stay organized and keep up with all of your units. And our result is 4.5 liters is equal to 4,500 cubic centimeters. I hope this helped you understand and practice unit conversions, and I'll see you in the next video.